both a pandas series and a numpy and d array, bool is not implemented, or rather it is implemented, it's just implemented return a value error. And so, a lot of the guidance that we might have on what this actually means is missing because it's implemented here. It just always returns an exception. But do note, of course, that the pep8 example, that pep8 tells us to do something that breaks with a numpy and d array or a pandas data frame isn't the end of the world, because you could think that in the case of a Python list, it's very likely that you might create that list, append something to that list, clear that list out. And this code is here. It's just saying, was there anything that I would bother to iterate over? Is there anything left over? In fact, we might even have some code that looks like this that just doesn't iterate at all. But if we have a numpy and d array, we can't append to that ND array. We can't clear out the values of that ND array. So this code is saying, if it were to be interpreted in the same way as the list code, it would be, did this array have any elements in it? But why would we be asking that question? If we didn't know if this array had any elements in it, we couldn't really do that much with this array. Because how would we know if it broadcasts against another array that we're operating on? And if this represents a mathematical structure, how often is it the case that we either have a vector in R2 or a vector in R3 or a vector with nothing and we don't know which one we have for the given problem we're trying to solve? Very unlikely. That isn't to say that this might never appear. Obviously, in some library code that's not really concerned with the mathematical use of the numpy and d array, but concerned with some other systematic use of this, some other mechanical use of this, we might want to say, oh, does this vector have any entries or not? And then make some decision based off of that. But in the use code for this, it's quite unlikely that we'd actually see this, because when would we not know if we had any entries? And as a consequence, we might need to, or we might say this isn't such a big deal. I guess the only thing I can think of is if there's some masking operation that we're performing, maybe here, something like this, because we don't know how big that mask is going to be. And there, maybe the pep8 guidance is not that great, but you can easily see where in many cases the pep8 guidance is completely fine. Note that the entire reason we are trying to use these underscore or these data model methods in Python is to interact with the Python vocabulary. That is to say, to be able to write some code where the reader of that code finds that code completely obvious. Somewhere deep within a program, somebody sees v equals object of k, and they say, that's a dictionary-like lookup. That's the get item protocol, and I can make certain assumptions. For example, maybe if I'm not guaranteed for k to exist, and I can do something if it doesn't exist, I need to look out for index error. So maybe I should wrap this code in a try except. Or if, for example, I'm running this code on the command line, if v equals object of k takes more than 15 seconds to run, something has gone wrong. Usually the get item protocol is something that's fast. It's usually something that's stateless. It's usually something that errors out only as the consequence of an index error, a key error, or more broadly, a lookup error. Whatever the case may be, we have some certain expectations that we have when we see a line of code like this, independent of what object actually is. Could be a collections.default dictionary, a collections.order dictionary, a collections.chainmap, a collections.counter, pandas.series, a pandas.data frame. It could be a numpy and d array. It could be a custom object of our own design, but all of these objects support the same general intuition. And so when we see that line of code, we bring the same intuition that we have from using all of our built-in types, and we say, okay, I have a sense of what this code actually does, and I have a sense of how to determine whether this code is correct or not. However, when we are implementing this vocabulary, well, we want to make sure that our implementation of these data model methods is implementing the one singular, unique, privileged operation for that given type. If we have a pandas series and we use the square bracket directly on the series, this will work. But it's ambiguous. Am I looking up elements by position, or am I looking up these elements by label? And if we actually look at what happens here, this looks things up by position, and this is looking them up by, actually this is a positional lookup, and this is a labeled lookup. Because you can see here if I do that, that is not inclusive of the end bound, so that indicates a positional lookup. And here you can see if I do that, that is clearly actually, let's shift this a little bit. So you can see that's clearly a labeled lookup. This is ambiguous. And in fact, it even takes me a moment, and I wrote this example to figure out, wait, which one's the by label, which one's the position? This is a bad idea, because somebody's going to look at that code and they're going to have no idea. Will this lookup succeed or fail? I don't know. Is this the index value or not? Is there some additional modality where it'll even look at this value and say, if I do something like this, is it going to try and intelligently figure out for me that, oh, you actually meant to do this by label instead? I don't know. And this ambiguity makes it much harder for somebody to work with this code. It leads to all sorts of issues that they may have. Here you can see that actually worked. It just probably shouldn't have worked. This is why when we're working with the Pandas series, we use our .lock or our .ilock. This makes it unambiguous. This is always a label-based lookup. This is always a positional-based lookup, and there's no hidden thing behind the scenes that says, oh, except under the circumstances where I look at this thing and this thing couldn't be a positional, couldn't be an index, and thus I interpret it as a label. Here, this is unambiguous. And I look at this code, I know exactly how this code will work, what this code will do, and whether this code is correct or not. It is critical when we implement these parts of the Python vocabulary, we implement them such that they're unambiguous, because otherwise, what's the point? And that means we must be implementing either a unique or a privileged operation for that given piece of the vocabulary. Consider len on a pandas data frame. Is that the number of rows? Is that the number of columns? Or is that the total number of entities? Well, the dot size is the total number of entities. And just like a NumPy and D array, there is a dot shape that gives us the shape of this, the number of rows and the number of columns. And we can explicitly ask how many rows are there and how many columns are there. But what does len all by itself do? Well, in this case, I would argue that this is not a problem. And the reason this is not a problem, that there might be an ambiguity here is, well, there's a privileged operation. When we perform operations on a pandas data frame, we are almost always performing operations down the rows. It's a privileged axis. A pandas data frame has a major axis, the rows, and a minor axis, the columns. It is always we're performing the operation down the major axis. As a consequence, it makes a lot of sense that the len is going to give you the size of the major axis because it's privileged. Although that may not be obvious to other people, in which case maybe we might want to be more explicit. Now, one small detail that we might or might not like about this is if we loop over a data frame, we loop over the names of the columns. So the len of this data frame no longer matches the number of iterations we get when we loop over this data frame. I don't know if that's a problem. And I think that likely people who do this looping over the data frame already know that it gives you the column names. And so maybe that's not such a big deal. But that could be the one reason why you might say, you know what, this itself really should be more explicit. And this itself should be more explicit because not everybody is going to know that. And a given user may not have enough background knowledge to be able to just eyeball that. Note, when we break the intuition, we not only really aren't accomplishing anything, but we're making things worse. We can impede understandability. For example, if we have some code that implements the getItem protocol, or here, the missing part of the getItem protocol, and we see some code that looks like this, is it safe in an update for us to transform this call that does the lookup twice into a call that does the lookup once and then reuses that value? Well, if our getItem is not stateless, if it's not pure, then this is not a safe transformation. We'll see a difference of results in our program. If it is pure, if it is stateless, as is the common expectation when we perform the same operation on all these other common structures that we work with, then it is a transformation that we can rely on. When we break these assumptions, we lead to users getting even more confused than if we hadn't even bothered in the first place. And we can lead to users making mistakes because they bring assumptions that they derive from their use of tools like pandas or NumPy or the built-in types, which leads them to write code or to make or to change code in ways that might be contrary to what we're supposed to do, or might introduce changes they don't expect based off of the actual implementation of that data model method. Now, sometimes there's a little bit of leeway here, because if you think about what the dictionary's OR does, this breaks our mathematical assumption of commutativity. That is to say, D0 OR with D1 updates D0 with D1, D1 OR with D0 updates D1 with D0. And so we get different results. We'd expect that this OR would look the same either way. But at the same time, even with Python sets, that's not the case. Set 1 and set 0 are equivalent, which is not the case for the dictionary updating, but they strictly contain different values because the true and the one value are otherwise equivalent. So it'll just take whichever one it sees first. And also, when we think about things like the mathematical operators on container types like strings or lists, this is also not commutative. When we add the strings in different order, we get different results. So it's unlikely that we're going to assume, oh, some arbitrary rewriting of this expression to swap the operands is going to be correct. And it's fairly likely within the code that we're writing, we'll know if we're working with strictly mathematical entities or if we're working with entities that are some kind of collection type. And as a consequence, while we might not know exactly what collection type we're working with, we're going to know that, okay, plus or when implemented on collection types isn't necessarily commutative. And so even though we break an assumption, it's a very minor assumption, and it's one thing that we would have in the back of our minds anyway when reading that code. So does this make things more understandable? Absolutely. Correct use of the Python object model, including an understanding of how the rules and the conventions conform or control what the meaning of these different pieces of vocabulary mean, and how our conformance to those rules and those conventions then further leads to code that is intuitive and understandable. Well, all of this does lead to end users who are reading through some code, and it just works the way they'd expect. It works exactly the way that everything else that supports that part of the Python vocabulary works, and they don't need to reach for documentation. They're not scratching their head. They just say, anything that I already know about dictionaries applies to this thing with get item. Anything that I already know about a similar type applies to the thing that I'm working on here. And so I can bring all of that knowledge to bear.
Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.